Welcome back to the Junior Penetration Tester pathway. So in this video, I'm going over SQL Injection Room. Okay, so we are presented with the level 1. The level 1 where we have to go over the application here, induce an error based on a mishandled SQL statement and find out how we can take advantage of the error statements to conduct a successful SQL injection attack. Now, this is part of the in-band SQL injection. So the in-band means that whatever you type, if you type something like code here, the application will produce an error. Means that you can just take advantage of the error, understand what is the DBMS that handles the queries or that hosts the database. So when you get an error like that after entering an illegal character or an unexpected input, you can say that you are dealing with the possibility of in-band SQL injection vulnerability. So what's required here is to find the flag. So let's go put this to the right and then understand more how this application operates. So as you can see from the error statement, the DBMS or database management system is MySQL server. This helps you a lot in determining the kind of SQL queries that you have to apply in this URL. So, for example, if we get back to one, so what is the corresponding SQL query for this URL? So let's type this here. So let's say select star from article. As you can see, this is the table where ID equal 1. So the table is article and the primary key of that table is ID. So I want to display all of the records on the table article, right, when the ID, which happens to be the primary key, equals to 1. This is the SQL statement that is executed when you try to access this URL. Okay. Now the semicolon here marks the end of the SQL statement. So how can I manipulate this query for my own advantage? So what I would like to do here, after we have determined that we are in an error-based SQL injection vulnerability, here the objective is to dump all of the records on the database. We don't have a login form, right? So here we have a URL parameter where we intend to manipulate the parameter in order to execute SQL injection of our choosing. So here, if you want to dump all of the entries in the database, you have to take advantage of something called the union statement. So, for example, this is the SQL statement, right? What I can do here, I can type union select 1. Okay. Now, if I take this, only this one. So up until ID equal 1, it's in the browser. So type 1 here, and after 1, type union select 1. You see here we have also an error. What's saying? The use select statements have a different number of columns. So the first thing I see when I am presented with this statement is that I have to determine the number of columns in order to display all of the be able to display data, right? So what I can do here, I can go back to my query and type 1/2. Thus, here I am assuming that that the database has 2 columns. Let's try this one. Or only this part, I guess. Again, we have an error. It means 2 columns is not the correct number. So type 3, keep increasing until you get no errors back to your screen. So type here, and as you can see, no errors now, right? It means the table article has 3 columns. So once you have determined the number of columns, you can proceed and enumerate the database. For example, you can substitute whatever command you would like to execute with one of these numbers. So if you go back, let me take this one. So this is the correct statement, or the legal one. I'm going to take this again. Okay. Now, next thing I would do is, let me remove this one. I'm going to keep only the part that is changing. So next thing, I would type the same query, and instead here, I want to know what is the database running. Database. Hi. So seems like we've got nothing. Let's try without the semicolon. What if I type 0 here? Okay, so now this worked. So here I changed just the ID parameter, the value of the ID parameter, and I got results, which is the type of the database, SQL I1. Now, after determining the name of the database, you want to start enumerating the tables and the columns. So if I want to gather a list of the tables, what I would do here, I will get back, and let's say union select 1, 2, and I would change this one, database. So if you want to dump all of the tables, what you would do here, you have to use the group concat table name. Here I want to dump all of the table names. Okay, from information schema dot table. Why information schema? Because information schema is the table that contains, or the database contains, all of the information about the other tables. That's why also we query information schema about other databases. Now where I specify the condition, table schema, the name of the database we got was SQL I1. Now take this part and execute. Leave the 0. So we have 3 tables: article, staff, article, and staff underscore users. So I'm interested in dumping the columns of the staff users. So next we construct the following SQL statement. So you may take this as is. Oh, come on, no. Just like that. All right. So you union select group concat. Instead of table name, I'm gonna aim for column name. From information schema.columns, where here I'm gonna change this to table name. Specify the table name, which is staff users. All right. Let's see now the columns on this table. The columns are ID, username, and password. Now we are close to our target. We want to dump the username and the password. So, getting back to the same query, constructing a similar one. So what we're going to do here, we're going to say union select 1, 2, group concat. So here I would like to dump the username, right? And also dump the password from staff users. No need to type the information schema or anything, because right now you have the table name, you have the column name, just have to dump it from its own table. Staff users. Let's try this one. Now I should be able to access the username and password. Meaning you have to get the flag after this. So this is the username and this is the password. Nope. I guess, let me check again. Admin password. So I guess here the password is mixed with the username, right? So what we can do to separate them is to use the BR. So basically here password, what we can do, we can type separator and use BR just to put them, put every set of credentials on its own line. So admin, Martin, Jimwork. Still we cannot identify which is the username, which is the password. I know just you can say this is the password, this is the password, but here it's not clear what is where the username ends or where the password starts. So let's use some kind of separator between the username and password. So here you can type, use the colon separator. Now it's way clearer. So we have the admin and password. Now we can just use, what's the question? What is the user Martin's password? So we can take this one and check if it is correct. So we have the first flag. Okay, that flag answers task 4 question. Now we go to the next level. So go now to the next level. Click on this button. Here? No, here. This is the next level, guys. The next level is using SQL injection to bypass login forms. So bypassing login forms, so this is for the first. I'm going to delete these. Alright, and start from scratch. So first, in order to understand how to manipulate the current SQL statement that gets executed when you try to log in, we have first to know what it is, right? So what happens when I type in a username and password from an SQL perspective? So what's going to happen here? Select, right, star from users. So the web application now will execute the following statement, where username equal, say here the supplied username. This is the supplied username by the user, right? Your inputs, and password equal password limit 1. Limit 1 displays only one result. So basically that's what happens when you type in a username and password and database, and if the database was SQL, the following query gets executed. So now this is kind of conditional SQL statement. As you can see, the statement here would get executed if it founds a username and password that already exist in the table users, right? So if you want to manipulate this statement and get access to the admin panel, what can we do here? Say here we type an admin, right? I want to get access to admin. And here, for the password field, in order for my SQL statement to get executed, I have first, as you can see, type in an existing user. I'm going to aim for admin. The first conditional statement is true. The username admin already exists in the table users. And the next, as you can see here, the next condition is that the password that I will type matches the password of the user admin. And because I don't know what is the password of the user admin, my statement or the SQL statement will fail to execute. That's why I have to bypass this condition. What I can do here, I can use or I can manipulate the logic of this statement, such as it always becomes true. How can we do this? Let's copy that. So the first thing here, type in admin, let's say, okay, and the password. So instead of, as you can see, we have double quotes. So what's gonna happen here? I'm gonna leave this empty and remove that one. So here type or 1 equal 1. So now the condition here always evaluates to true. So the first thing is gonna look for admin. Is admin within the users, within the table users? Yes, it is. So next it's gonna evaluate the next condition. This is the next condition. The next condition is the password of the admin equals to empty, and this is not correct. But we have an OR statement here. An OR statement means that one of the conditions here, all right, needs to be true in order, only one condition needs to be true in order for this statement to be evaluated as true, right? So since 1 equal to 1 always, right? So what's gonna happen here? We're gonna be able to execute this SQL statement and get access to the user admin. So that's what happens behind the scenes. What you can do now, you can go back and just type in admin. Next, this is capitalized. In the password field, you can type or 1 equal 1. Not found. Okay, let's take with the one single quote, see if this works. So what we can do here, actually, we can type in 2 dashes or 2 hyphens. What's the reason for that? We want to comment out everything that would come after this statement. Maybe there are further checks and we don't know about it. So here we comment out everything after our statement that we have typed to comment out everything. So now we can take this one and use it here, and now it worked. As you can see, we bypassed the login and can now move on to the next level. This is the flag for the admin user. And this is for the SQL injection for authentication bypass. Blind SQL injection, it means that whatever you type in the login form or in the search field or in the URL parameter value, even it produces an error, you won't be able to see it back in the output. All right, next one. So next level. The next level is Boolean-based blind SQL injection. Boolean means whatever you do, it always equals to true or false. Okay. So say here admin, the username admin exists, right? So the result is true. If you type something that is incorrect or it doesn't actually exist in the database, it's going to return false. So that is Boolean-based SQL injection. So see here, what do we have to do? All right, so we have here again a login form. I'm gonna refresh this. Okay, so see here we have a login form, and also we have a URL, an address bar. We have a URL here. Check username equal admin. So it checks if the user exists or not. If we type something like AD, as you can see, it's false, right? So we want to manipulate this logic. We want to use the outputs we have here, whether it is false or true, to determine if our SQL queries that we will be composing are actually correct or not in order to dump results or dump the information from the database. So first, let's understand what is the corresponding query to this URL. So you go back. So what's going on here is select star from users where username equal to the supplied username. Limit 1. That is the actual SQL statement that's getting executed every time you type something here in the username field. Okay. Now if we type something like 1, 2, 3, saying false, 1, 2, 4, say user here, type in user. So there is no such username called user. All right. So what we can do now, we can use the same reasoning we used with the first level, with the error-based SQL injection. Here we intend to dump all of the information and all the records in the database. All right. So here we return back to our friend union select. But here, as you can see, the username, the input that you put here is quoted with single quotes. So whatever you type after this statement, it has to end with, or it has to start with one single quote. So what I would do now, I would type in a username such as user, right? End it with a single quote so that the statement here becomes correct. One single quote from the application. I typed in here user, and then I close that with single quote. And after that, I can type my SQL statements. For example, union select 1. And I use the comments here just to make sure everything is commented out after that. Let's see if this returns true. If it returns true, it means I have one single column in this database. False. Okay, we increase them. I'm going to try directly with 3 because the correct number is 3. See now the output that you will get from the web application. It's true, which means I have actually 3 columns. Then I can execute and enumerate the database just much like I did with the first level, with the error base, right? Next, I determine the database, and I determine the columns, tables, and finally the password or username. So the next statement would be this one. And now, because we're dealing with Boolean-Based, right, we have to modify a bit the SQL statement. In a real-world scenario, right, you don't have the luxury of getting this output. Most of the web applications are blind. Even if they are vulnerable to SQL injection, you won't be able to know what kind of SQL injection to try, right? If it's Boolean-based, it is error-based, whatever, right? So you have to try all of these statements we are doing in the challenge. There is no specific way to bypass all of the web applications filters, right? So what you can do here, we can just understand the overall methodology, and then when the time comes, you can try all of these on your own. Of course, you can use SQL map, but it's always a good idea to understand the manual method, since sometimes you have to enumerate on your own, and the application itself, just like SQL map, won't give you, it may miss that the application is actually vulnerable. So union select 1, 2, 3, where, say, so we're going to use where statement, database, like, why I'm using the like statement here? As I said earlier, here I am dealing with Boolean-based SQL injection, right? So the output is either true or false. I can't just type the database here and substitute the command with 2 or 3 because the application will not return me the type of database. It's going to say either false or true. So for me, I have to guess the name of the database myself, right? And see if the application will tell me my guess is true or not. So that's why I'm using the like statement. The like statement here will actually execute this command, right? And will look for all of the um, possibilities and see if the database name starts with S. If the database name starts with S, the application will say or will return true. So I can continue enumerating further until I find out the name of the database. So what you can do here, you can just copy paste that. See, it's true. What does that mean? It means that actually the database starts with the letter S. Okay. Now, the next thing you can do here is the same. Just type here. You can continue on enumerating through all the letters A, B, C, right? Until the application tells you or returns true for you, right? It means you can continue on to building the string of characters that would finally correspond or equal to the database name. So if you type here SQLi, say it's true, which means that the database name actually starts with SQLi. Now, you can continue, as I said, trying and using characters until you arrive to the final name. The final name of the actual database is SQL_3, and this is based on the previous levels. The first challenge, the SQL database name was SQL_1, here 2 and here 3. That's how I guessed the name. So in order to know if that name is correct or not, I'm gonna use _3 and remove or take this one and put it here. So now the difference in the like statement is the application will return true if the actual name of the database is SQLi3. Let's use that and get back. So now if it returns true, it means SQL3 is the actual name of the database. True. So the name of the database is SQLi3. So now we have determined the name of the database. The next thing we would do, guys, is to enumerate the tables, the columns in this database. In the same reasoning or the same logic, what we can do, you can just take the statement. Okay, no, here. Now, next from information underscore schema dot tables, right, where table schema equal SQLi3 and table name. We don't know table names, right? We don't know the name of the tables. That's why you have to determine it ourselves using the like statement. Like, yeah. So now here we aim to determine the tables at this database. So here, what we're gonna do actually, you're gonna go through a long sequence of manual work. You're gonna type, actually the A here, it should be here. So you're gonna iterate through characters, numbers, until you construct a full name for the table, right? And this is a long manual work. But since you are able to understand the and comprehend the logic of the statement, you'll be able to use SQL map to do that for you. So now you can continue on, right? Enumerating. I'm not going to do that on my own right now because it's going to take time. But just here, I'm going to tell you what is the correct table name that you will be enumerating. So basically, we aim for the table users all the time. So I'm going to just type US here and see if a table in the database starts with the US as a name. It means there could be a table called users under this database. So it's true, right? I'm going to try my luck now and type users here. Take this. And now I want to make sure, or I want to see if the application would return true for this database. If it returns true, it means there is actually a table called users under the table schema SQLi3. So I can continue enumerating on this table further with the columns. So this is true, which means that we have a table called users, which is the only thing I'm interested in right now. So next I would enumerate the columns. So I would use the same query here. I'm going to replace tables with columns. Table schema, it's going to be table name. No, table schema stays the same actually. Table schema equals SQL I3, and table name here, I'm going to remove, we're going to be equal to users. Right, and lastly, and column column name here. So yeah, underscore name actually, it should be underscore name, follow the same formula. So column name like, and you go again with the sequence. So much like we did with the previous ones, I'm gonna jump directly to the column name that I'm interested in. So basically I'm gonna try username, see if it exists. See if we actually have a column name called username. True. So we have a column called username under the table users, right? Let's try with password. And it is true. We have a column called password under the table users and database SQL3. What's your next job now is to guess the username and the password. So again, take this one. No, we don't need these anymore. Since we have determined the column and the column names and table names, now we start to guess the username and the password. So what will you do here? You use user, select 1, 2, 3 from, just like that, from username or users, table users, where username. Now we start guessing, right? Like, say I want to make sure if the user admin actually exists. So I would type like admin. Let me try this one. See if there is a username called admin. And it is false. There is no username called admin. Let me make sure my statement is correct. Select 1, 2, 3 from users where username. Okay, let me try this one. If I remove this one and see if there is a user starts with ADMI. True. Okay. N. How about N? And it is true. So the username is actually admin. I don't know why it gave me false previously. Okay. Next, we guess the password. So it's the same logic. Take this from users where. Now you go over the password guessing process where password or username first equal admin and password like a. That's the first thing you would do. First, you select the users table where the username equal to admin, and here you start guessing the password. First, for example, here it's gonna look in the table where the username equal to admin and see if there is a password that starts with A. If this is true, it's gonna tell you this is true, and then you continue on with the next character until you reach the final password. Don't forget to use numbers. All right, so to make things um, you know, short, the password is not characters, the password is composed of numbers. So if you try 38, it's going to tell you it is true. True, right? So you continue on with numbers, you know that the password is composed of numbers, and you continue on with numbers until you find the final password. So here the username is admin and the password is 3845. And here you get the flag for task 7. Now the last task for this video is task 8. In task 8 we use, as you can see, time-based blind SQLI. Time-based, it means here the pen tester use time comments in the SQL query to know if his SQL statement is correct or not, or if it's actually going to return the desired output or not. What is a time function in SQL? It's called sleep. So let's get rid of all of that, and now understand more how we can, take advantage of time-based vulnerabilities. See here, an example would be referrer. We have the URL here. The parameter is referrer and the value is tryhackme.com. So when I type tryhackme.com, enter the time to process the request was, as you can see, fraction of seconds. But if I try something that is not supposed to be the correct value, such as single quote, it took 1 second. If we type 1, of course less than 1 second, fraction of seconds to process the request. So that's how we take advantage of the timing. If the request has been processed quickly, it means that we've got nothing, right? If the request took notably more time than it used to or supposed to take, it means that we have got something to use with our query. It means that there is something we can do against that application, right? So how can we do this? If we go back and type something that's not expected by the application, such as user, right? All right, I know, fraction of seconds. That's good. Let's construct now the corresponding SQL statement. So user here, right? And then type union as before, select sleep for 5 seconds, let's say. So here, if the application responded quickly, it means that the number of columns I assumed in my statement is not correct. So here I'm assuming we have 1 column, okay? Let's try this. If there is 1 column, the web application will respond after the specified number here. Try it. You see, it responded quickly, a fraction of seconds, which means that your SQL statement is not effective. If it was effective, it would execute the sleep 5. Now I'm gonna jump directly to the number of columns. We have 2 columns. See now, when your SQL statement is correct, what's gonna happen? It's gonna execute the sleep function here, and will sleep for the specified amount in the value. So here it is sleeping now for 5 seconds. As you can see, the response came out after 5 seconds, which means I have 2 columns. Now, the next thing you would do is to continue based on the methodology we used with the Boolean-based SQL injection. So next here, we determine the tables, columns, but from the perspective of the time-based SQL injection or the Boolean-based SQL injection, because they are the same. So now, the next step would be user union select sleep 5. Keep the sleep 5 as is. You want to make sure that your output or your input actually or the statement is correct. And here in the next column we type 2, and then where we want to guess the database name, right? Database like, and we start with the same process. You look for a database name whose first character starts with U. So database name actually directly it's SQL I4. So if I type SQL I like that underscore 4. Now it's gonna take 5 seconds to respond, which means there is actually a database whose first characters are SQLI. As you can see, it's taking 5 seconds to respond. After 5 seconds, we received a response under 5 seconds, which means SQLI is actually, there is a database whose characters start with SQLI. It's SQLI4. Now to extract the flag, what you are about to do here, are about to go the same process we went through when we were doing the Boolean-Based, right? So first we guess the username. So what you do here, users and also select take until where. So here type from users where, suppose we have a username called admin, and now we want to guess the password. The password is composed of numbers, say 1. It starts with 4 actually. And you can tell me how you know that I did this before. So just saving time on you guys. Next, single quote and column. See if this is if this statement will return true, or will actually will make the application sleep for 5 seconds. If it is, we will conclude that there is a username called admin whose password starts with 4. And as you can see, it's successful. The application now is sleeping for 5 seconds, and it has returned OK after 5 seconds, which means there is a username called admin whose password starts with 4. Let me type 6 here. Wait, from here. 6 is not correct. Let's try with 5. I forgot the password actually. That's why I'm trying with different numbers. Okay, try with 8. I hope 8 will work. Nope. Okay, 2. How about 2? I don't remember it was 2, but let me try anyway. Okay, how about 3? Let me do the full URL, way easier. How about 4? Nope. Okay, 5. How about 9? Let's try with 9. I think 9 is the second correct character. Yes, it was 9. So see here, it's taking 5 seconds to respond. Alright, now the next character, I remember it was 4, right? Let's try 4. Nope. Okay, about 6. Yeah, it is 6. So the third number is 6. Now you got one last number. 8. Let's try with 8. Nope. Let's try with 4. 4, 4. Nope. 5. Nope. 6. Nope. I guess the final answer is 7. Nope. How about, did we try 9? Nope, I don't think so. We are close to reach a rabbit hole for this. We can't find the correct number. 7. We tried 7. How about 1? I mean, there should be a number. Yeah, it is 1. So the username is admin and the password is 4961, and you've got the final flag. So that is the SQL injection room, guys. So this is the final flag here, injection master. Next thing, there is no required flag. Lastly, no required flag. And now we mark the end of this room. I hope you enjoyed that. If you have any questions, just, can send me. And I will be adding what we have learned from this room to the notes file. If you want to subscribe to the membership of the channel, you can subscribe and get the notes. Thank you very much. See you in the next video.